Okay, section 26, part 2. Still looking at the sine and cosine rule in three-figure bearings. So we've got, in the diagram below, P, Q and R represent the positions of three towns, Portley, Queenstown and Rushen, respectively. So I'll just draw that out. So Rushen, Queenstown, Portley. Got an off symbol there as well. Portley is 25 kilometres due south of Queenstown, so that information was given in the question. That's pretty straightforward. Also in the question was given is from Portley the bearing of Rushen is 0.72. So from Portley, from north in a clockwise direction to get to Rushen, that's 72 degrees. Now the next piece of information is from Queenstown the bearing of Rushen is 128 degrees. So that information was not put into the diagram, but it's down in text form. So from Queenstown the bearing of Rushen is 128. So from Queenstown north in a clockwise direction, that's 128 degrees. The question then says calculate the distance between Portley and Rushen, which is that. So I'm going to call that small p, small r. Now before I get going, let's see if I can find out as much information as possible. Well, I can see a straight angle, 180 degrees. So I can get this small angle in here, because it's going to be 128 off of 180. And that will be 52 degrees. Now, I can then find the third angle, because the angles in the triangle add up to 180, and should you go ahead and do that? Well, I definitely would, because it could be useful. So 52 plus 72 gives me 124, and then take that off of the total of 180, and that will give me 56 degrees. Okay, so I could interpret this again as a sine rule question. There's my unknown. There's the angle that faces it. So two pairs of opposites and one unknown. Q over sine Q equals R over sine R. That's a sine rule question. I then put the information in. So Q is what I'm looking for. So Q over sine 52 is equal to R, which is 25, over sine R, which is sine 56, and then cross multiply. So sine 56 times Q is equal to 25 sine 52. Then bring the sine 56 down and divide, and that will be Q equals 25 sine 52 divided by sine 56, then input that into the calculator, and to one decimal place that will be 23.8 kilometres. Okay, next question I've got, in a race, boats sail round three buoys represented by A, B, C in the diagram. There's then some information in the diagram which I'll draw just now. So the information in the diagram is shown, and that's given to me. So I've been given the three sides, and I've been given the size of this angle here. So B is 8 kilometres from A in a bearing of 0.60. C is 11 kilometres from B, and A is 13 kilometres from C, and I'll put the letters in here, so that's A, B and C. First question says calculate the size of the angle ABC, so that's this angle in here. Well, I don't actually need to do any work in terms of finding extra information out, because I've got enough already. I've got three sides I'm looking for an angle, and that's cosine rule for an angle. So cos of B is equal to A squared plus C squared minus B squared over 2AC. So that'll be small a opposite big B, that's small b, and that is small c. So I'll then substitute this information in. So cos of B equals A squared, 11 squared, plus c squared, which is 8 squared, minus b squared, 13 squared, over 2 times a, which is 11, times c, which is 8. So that simplifies down to cos b equals 16 over 176. It's then b equals cos inverse 17 over 176. Put that into the calculator to find the size of the angle. That will give me, to one decimal place, 84.8 degrees. Okay, so now I've got a value for the size of this angle, which is 84.8. Now, part B is to find the size of the shaded angle. Now we can see that there's a Z angle here, and if that's 60, this bit in here would also be 60, since that's a Z angle. So that angle there is 60. Now we know that the full angle is 84.8, but if this bit of it is 60, then this bit of it here must be the remainder of it. So that's 84.8 minus 60, 24.4. Now we can then see that this full angle is a straight angle 180 degrees, and that the shaded angle there is the straight angle minus this bit in here. So 180 take away 24.4, and that will be 155.6 degrees. Okay, next one. We've got Jane is taking part in an orienteering competition. She should have run 160 metres from A to B on a bearing of 0.32. However, she actually ran 160 metres from A to C on a bearing of 0.52. So from north in a clockwise direction, she should have went 0.32 degrees to get to B, but she actually went from north clockwise 0.52 degrees to get from A to C. Now 52 degrees and that bit's 32 means that small angle in there is 20 degrees. The question is then looking for the size of this length. So two sides with an angle sandwiched in between, and that's cosine rule for the side. A squared equals b squared plus c squared minus 2bc cos A. And then input that information. A squared equals 160 squared plus 160 squared minus 2 times 160 times 160 times cos of the angle in the triangle, which is 20. So that will give me that number there. I then take the square root of that number to find A, and to one decimal place that will be 55.6 metres. Part B then says, what is the bearing from C to B? So from C, remember, from north in a clockwise direction, we need to find that angle which will take us to B. Well, if we split this up, well, from north to south, first of all, is 180 degrees. I can then identify a Z angle here. So that's 52 degrees, which means that bit in there must be 52 degrees. So 52 and 52. Now I know that it's an isosceles triangle because these two lengths are the same, which means these two angles need to be the same. That angle down there was 20. So 180 take away 20 will give me 160. I then half 160 to get one of the angles. We know that they're both the same, and that will give me 80 degrees. So that bit in there's 80. And then just add everything up. 180 plus the Z angle 52 plus the internal angle in the triangle 80. And that will give me 312 degrees.